And Charlie, I think you're muted here. If you want to unmute yourself, go ahead.
Hey, yes, thanks for those cues and should now see my screen. We've got a presentation we can walk through, but yeah, I kind of had to ask twice of Troy, you want to hear about natural gas. This is a sustainability group and you guys want to talk about natural gas and yep. Okay, so just wanted to make sure we got the topic right here today. And yeah, I'll do just a quick introduction to our company, Competitive Energy Services. We were founded in 2000. We're based in Portland. Our kind of home territory is Maine and New England. It's where we live and do most of our work here in this deregulated electricity marketplace. But I think some important things about us and our ethos here are that, we are an independent company. We have the benefit of working for our clients and looking out for their interests. We have a kind of transparency in how we charge and align ourselves for that purpose. And we, although we have some standard services, everything we do is in a way customized based on our clients' needs. So it's a really fun company to work for, dynamic industry. We've got close to 45 folks that work here, but also out of their homes throughout New England. And yeah, that's kind of CES in a nutshell. Half of our business, really is based in traditional commodity procurement. We help bring, in the most cost-efficient manner, the products, electricity, natural gas, et cetera, to our customers. We help them procure that energy and provide advice and guidance on what the future looks like, so we can make decisions around hedging and contracting to meet both the customer goals and based on what's happening in the market. So that's kind of our core competency, is building out kind of this information and data set about what our clients need. We also have half the business in kind of a consulting bucket, where we're advising on budgets, forecasting costs, and providing monthly reporting to various end-use sector customers across a spectrum of needs. And a lot of that is starting to fall in this kind of decarbonization planning category, where we've got an understanding of what people use, an understanding of where they want to be by 2030 or 2040, what have you, and helping to start visualize and implement those transitions as part of the work we do. So this is kind of how we compartmentalize our work: procurement, consulting, reporting work, just to give you a sense of who we are. And that covers a range of traditional commodities, but also now any renewable commodities that our clients are buying. We do the same kind of procurement, consulting, and reporting on anything that our customers are needing or wanting to buy. So that, just for background, didn't intend to spend too much time on that. Not an infomercial, but just to give you a sense of kind of who CES is. So the presentation today is designed around natural gas, and you'll notice a little bit of a transition at the end. But I think first, for alignment, I want to just categorize the market or pricing for natural gas into three categories, just for you to think about and take away from this presentation. The first of which is the commodity of natural gas. Think about the molecules and the actual physical gas, which we call the commodity. Second component is this interstate transportation component that we refer to as basis. The cost to get that gas from the point of production or a storage location or a price liquidity point to where your local distribution company or utility takes ownership. So it's kind of a transportation piece that is often a bit of a black box. So that's the second component. And the third component is more clear and obvious, which is your local distribution company, whether that's in Massachusetts, one of the, Eversource, NGrid companies, or up here in northern New England, Unitil or Bangor Gas, et cetera. So that's the delivery component, local delivery company that owns everything from where the supplier drops it off at the city gate up to your meter. So commodity basis and delivery is how we're going to talk about gas and present today. So I got to choose which section I wanted. So I'm going to do the easiest one, which is commodity. And I guess a few takeaways here from natural gas commodity is that U.S. is one of the largest producers in the world now of natural gas. Our production has doubled in a really short time frame with the technology advancements in basically extracting gas out of these shale deposits. That's the primary growth area for our domestic, U.S. natural gas production. Our total production is almost 100 BCF, billion cubic feet per day. This is a record in time and history, and the trend is looking like it will continue. So one of the largest slices here on the top, the green, is relevant to us, in the Northeast, the Marcellus. This is one of the largest and most active shale plays in the United States, and it's also, pretty proximate to New England. I mean, really close to us. So, that's a good thing for, accessing the gas, or not for accessing, but it's good for us in that it's close. We have a huge resource that's close by. But there's some other issues which we'll get into in kind of getting that gas into New England. So, the question might be, all right, well, where is all this gas going? Right now we do export gas primarily out of the Gulf Coast. But other than what is presently put on a ship and, liquefied, cooled to super cold temperatures, put on a ship in a liquid form and sent into the global marketplace, all of our gas is kind of domestically produced, domestically consumed up to, this point in time. However, we're seeing, expansion projects that have increased our capacity to export that gas with, a projection of perhaps 25% of our production being capable of being exported out of the United States by the end of, or by the latter part of this decade, and even in the next few years. So some significant gains being made in what can physically be exported out of the country, and into the global marketplace. So talking about kind of price and how that works for the commodity, that's traded on the New York Mercantile Exchange. So sometimes you'll see the commodity price referred to as the NYMEX, but that's priced based on delivery down in Erath, Louisiana at the Henry Hub. Those prices you'll see in the blue line here, and y-axis on the right have been pretty stable over the past year, but coming out of a more volatile period in 2022, as Russia had first invaded Ukraine, that kind of upset the market quite a bit. But kind of fast forward to where we are in time now, record gas production. We're starting to put more and more gas into storage. If you look further out on the right side, our storage levels are increasing pretty significantly right now. This time of year is typical for that anyway, but the cost of natural gas for delivery, next month in April is so inexpensive, under $2, that all the gas, if you can get it into storage, that's where all our gas is going to go throughout the balance of the year. So you're going to see a huge amount of storage, US storage getting filled throughout the year here. And I guess the short story on natural gas commodity is that the US is flush right now until either production changes or we see greater amounts of exports. Prices are suppressed, and a lot of this gas is just getting put into storage with the kind of the hope or expectation that next winter or sometime in the future, those prices will go up and that stored gas will be more valuable than it is getting put into storage, sold into the market today. Just let me know if there are any questions. Just someone flag me down here if there's something coming in I'm not seeing. And otherwise, I'll turn it over to Chris, our Director of Natural Gas, to talk through some of the basis component. But that that's a summary of our natural gas commodities.
Yeah, thanks, Charlie. Good afternoon, everyone. This slide here takes a look at pipeline infrastructure in New England. So interstate pipeline infrastructure for natural gas in New England. The primary flow of gas into New England is really going to be twofold. One, from TransCanada to the west, specifically Dawn Storage, which we've got down here at Dawn Hub, right next to Michigan. That is a primary source of gas, especially into locations north of Dracut, Massachusetts, which you see right there on the very southern tip of Maine, New Hampshire there on this map. And the Dawn Hub will really feed any gas that is north of that point. South of that point, gas is going to come into the region on Algonquin. You can see that as it comes in to New Jersey and right in up to Boston. So those are the primary paths for natural gas into New England, the two primary paths. There's Tennessee, which is another pipeline, but those are our two primary sources. One thing to take away from this slide is that we have a finite amount of pipeline capacity, and that really drives basis pricing, and it's because it turns it into a commodity. You are literally competing for space on the pipe. As more and more of that basis or capacity gets sold for a term, it becomes more valuable, that remaining available capacity. Another interesting note here is because of our constraints, our pipeline constraints in this region, we have a couple. One is specifically around Boston. Others as the gas comes into Massachusetts. And with these constraint points, we need liquefied natural gas downstream of those constraint points in the middle of the winter to get gas everywhere it's needed. And as a result, we rely on pricing. We rely on liquefied natural gas to come in on boats, on cargo ships, and deliver that gas to us where it's needed. We have to compete with cargoes headed to Europe for that gas. And as a result, part of the cost component or the price component that goes into basis is that replacement cost of gas, which is the price of gas in Europe, since we would be competing with cargoes heading in that direction. One thing I want to point out here, and we don't have it on the map anymore because it's no longer there, but if you look up in Atlantic Canada, you see Canaport. And then further east, that is the Maritimes and Northeast Pipeline. And it goes all the way out to the edges of Nova Scotia. We had offshore Atlantic Canada production that fed into the Maritimes Northeast Pipeline and brought that gas right down into Maine, down to Dracut and into the pipeline infrastructure. Those wells have been shut in, and we're left with those two primary paths I outlined before. But we do not expect additional pipeline capacity to be built. Very tough environment to build new pipelines. And so we are left with what we see here for infrastructure moving forward, and we're going to have to manage around that. But that'll be it for this slide. One thing that we, on the next slide here, is that we take a look at, thank you. We take a look at the generation mix in New England. And this is competition for gas and on the power demand side. So as I mentioned, natural gas is used in about 55% of our generation. Nuclear making up 25. A lot of folks are surprised with that number. Renewables are at 14% and growing. And then other generations at 5%, and you can see where oil is all the way down to 1%, it being a very high cost of generation. The renewables are going to increase primarily due to, well, two things, technology, but also the renewable portfolio standard that has been set by the states here in New England. And that RPS standard just means that folks that are selling electricity into our markets need to adhere to a certain percentage of their generation coming from new renewable generation assets. But we are, since those RPS standards are increasing, we will see that percentage of generation increase as well. Mentioned that oil was the highest price. That and coal are used as backup in our region. I think one thing is that this will certainly change as we move to electrify everything. This generation mix will certainly change, and we'll see the renewables increase. Moving on to the next slide. One thing we have in New England that other regions of the country don't have is seasonality with regards to basis. So again, we're talking about reserving space on the pipeline. And in the wintertime, when the pipeline is filled to capacity and beyond, the demand for that gas obviously is very high, and space on that pipeline, I should say, is very high. And you see prices really can pop on certain days, and generally speaking, as this chart shows, for a season. Now, what we're looking at here is this upcoming winter, which would be from November of 24 through March of 25. And we're looking at the price of basis over time for that time period. So back in March of 22, the average winter basis at Algonquin, which is New England, was almost $9. And at Tetco M3, which is down in the metropolitan New York area, let's just use that as a general reference. Out of New England, not the capacity constraints that we have. They were all the way down to $1.66. So a big spread between the two. Tighter market, we're down to about a $4 spread. But the key point here is that we do have seasonality, and during the winter months, natural gas and basis are much higher than they would be the other 9 months out of the year. So with that, I can pass it along to Zach. So thank you all.
Thanks, Chris. And so if we think about that 100% RPS goal, that's really focused on electricity. But a lot of states in New England have also created more holistic, all-in carbon reduction goals, similar to end users like yourselves. And so in Massachusetts, for example, they've committed to a carbon neutral future by 2050. So if you go to the next slide here, the way that they want to approach this is thinking through really 4 pillars. The first pillar being end use energy. And so this is electrification, getting off of internal combustion engines, getting off of oil or gas use in boilers or energy systems, and really just switching from a scope 1 fuel to electric use. Step 2 is just not using energy or being more flexible about when the energy is being used. The third pillar is decarbonizing. Once you get it off of oil and gas and coal into electric, then you can create options, whether it's unbundled RECs virtual power purchase agreements. In Maine, a lot of the net metering agreements come with REC ownership, similar to in Rhode Island. And so it's much easier for an end user to really control the amount of carbon in their electric supply. There's not as many options in the scope 1 fuel switching. And the last kind of pillar being carbon sequestration. So as part of this larger greenhouse gas kind of reduction, there was a ruling to say, like, you can't put a goal out there in 3 decades and just hope you get there. We need to see intermittent steps on how you're performing. And so they created the baseline, of 1990. In 2025, they need to reach 33%. So we're currently on track for that. That's going to jump up to 50% in 2030. 2040, you need to get to 75 and then 100%. And so, it was really tough kind of looking from the sidelines at the RPS in Massachusetts, and this is similar in other states in New England, where there's these, 100% goals out in the future. And at the same time, they're providing incentives for fuel cells, for combined heat and power plants. And those were certainly very efficient, compared to a much dirtier grid, years ago. But if you incentivize infrastructure for decades out into the future, it's really changing what decisions would be made. And so I think the idea that there was an alternative portfolio standard that was incentivizing carbon-based infrastructure kind of came to a head in the last, call it half a decade. And so the real push now is to create things like a clean heat standard or a alternative energy, electric-based renewable energy credit equivalents. And so that's really how a lot of the funding is going to come for decarbonization, whether it's from cars with internal combustion engines or getting off of oil or gas-based, boilers to geothermal or air source heat pumps. So on the next slide, we can kind of take a look at really how far, we've come. And a lot of this is, very similar ratios in each state. We start from the bottom and to the left here. What we're looking at is the gross emissions by sector. And in 1990, transportation was almost 30%. The electric power, was about 28. Residential, heating 15, and commercial about 8%. And so the vast majority of our emissions were coming from that. So transportation, obviously, there's been electrification, but that didn't really speak to the decrease in 2020. This is more based on, California's CAFE standards, more efficient, cars getting away from, Suburbans to smaller cars to more fuel efficient cars, and then ultimately getting to, a much lower amount of carbon emissions. And I'm not sure if you see, Charlie, but the slides did switch. So the changes here obviously were pretty apparent on the transportation, sector. Electric power was also pretty obvious. We moved away from coal-based electric generation. A lot of oil is reduced and really only used in the winter for peaking. And then really the big change is the amount of gas that we used for electric generation back in the 90s was about 10%. And if we fast forward, now that, as Chris mentioned, we're up to about 50%. And so that was a huge boon for the amount of emissions per megawatt hour generated. We've went from over 1,200 pounds per megawatt hour to the 500-600 range, depending on the state that you're in. The last two kind of space heating, once again, you have the residential and commercial. Residential, especially up in Maine, was primarily based on the large geographic footprint using oil. There's not gas pipelines running to every single location, or just too costly, didn't make sense. And that has definitely changed. There's a lot more gas infrastructure, similar to electric. That was a big benefit for emissions reduction. But at a certain point, once again, it's still a carbon-based infrastructure. And the same goes for the commercial space. You can see that we dropped by almost a half over the last 3 decades, and now we really need to pick up the pace to get to the goals that are being laid out for 2050. And some of the really tough ones are going to be the very last ones, industrial process, industrial energy use. Some of the manufacturing requires certain energy requirements to produce that, but we've also seen a lot of strides. We're starting to hear about cement infrastructure that can come from a green electric supply, but those will be the last ones to change. A lot of our university clients or large kind of corporate campus-based settings have really focused on I'd call it the space heating and then the electric supply. So doing those VPPAs, increasing the amount of electric by electrifying away from those boilers to ground source, heat pumps and district energy systems that are much more efficient. And so we've made quite a bit of progress. We have a lot more to go, and I think those last ones will be much harder, the last 3 decades than the first 3 decades for these reductions. If we go to the next slide here, I think this is the crux of it. The natural gas utilities have not really been involved in the energy efficiency, greening of the grid and infrastructure. And not only that, there's lower, costs in there because they don't pay for all those administrative programs. That comes on the electric side. And so I think there's a fear here that the impact of electrification is going to be kind of multiple downstream impacts that are unintended but necessary. And so if we think about the gas utilities, they mostly have fixed costs related to their operations, management, and the gas distribution infrastructure, as well as the investments needed to expand that infrastructure. And how they do that is similar to electricity, where they spread these costs amongst their customer base. Now, this is obviously for illustrative purposes, but there's no way to get to a net zero carbon future if there's still gas infrastructure. And so if we think about how we've gotten off of oil, that increased gas use, but to now get to that next goal, it's going to decrease the gas customers. And so as we decrease the amount of gas customers paying these fixed costs, it's going to get more and more expensive for each end user. Every time someone leaves, prorated, it's going to go up. So this is going to be, I think, a really big issue that needs to be tackled. And this essentially necessitated the state of Massachusetts to open up a gas proceeding. And so what the Mass policymakers and regulators, need to simultaneously make sure are that the utilities don't fall into a debt spiral. Obviously it's going to be an issue if they're insolvent, if they're not taking care of their infrastructure. These gas distribution networks need to be phased out, in a reliable and secure manner. If people remember back in 2018, the Merrimack Valley gas explosion, this is kind of one of the fears that a deferred maintenance is not necessarily acceptable in buildings, as you guys all know, but it's critical it doesn't occur on the infrastructure side. The third kind of point that they're focusing on here is that ratepayers are not unduly burdened with exorbitant rate hikes. And then the last being state climate goals need to be achieved. And so coming out of this, really there's kind of 2 different ways to think about the outcomes of this, if you flip to the next slide here, what they committed to were kind of binding outcomes and then guiding outcomes. So the binding outcomes were to have non-pipeline alternatives, being considered under new infrastructure proposals. Primarily utilities really just want to put the most amount of steel and infrastructure into the ground. That's how they get paid on a return on equity. So they don't actually have as much risk, which is why they're monopolies, and they have some larger kind of issues there, under that premise. But if they think about, are there alternatives that are less costly and more carbon efficient, this can make a huge impact. The increased pressure on the gas LDCs to minimize these stranded costs is kind of first and foremost for one of the binding outcomes. Another big one, and we've already started to see it, in locations like Lowell and Framingham, is having targeted electrification pilots jointly conducted by not only the electric utilities, but the natural gas utilities. One such is, UMass Lowell partnered, with the city and the utilities to do a local geothermal, pilot, which isn't just for UMass Lowell, it would also cover city buildings, commercial buildings, and UMass Lowell. So trying to have, projects out there that are testing these technologies, not only for themselves, but more of a district, energy system like in the city of Boston. Another important one is kind of improved system planning coordination, understanding when people are electrifying, when transmission needs to increase, when distribution needs to increase, and simultaneously natural gas, decreasing. This was one of the issues that previously Attorney General, Healy had, was not funding, infrastructure upgrades for the natural gas. If we have these goals of 100% renewable electricity and decarbonization, why are we putting, millions and millions of dollars into upgrading a older system that doesn't need to grow? It needs to be more efficient. And so kind of allowing for that to phase out in tandem while the electric grid is being more resilient and hardened. And then the last one was allowing the utilities to kind of have climate compliance plans and tracking starting in April of 2025. The guiding outcomes were more about, having those energy efficiency programs, the incentives, not come just from the electric side, but also from the gas side. So if the gas utilities are involved and have some sort of vested interest in electrification, then maybe it softens the blow a little bit. But as it is right now, it just means one more customer is defecting every time they electrify. Just like electric buildings and kind of EV cars have their own rate designs, doing something similar for, a hybrid heating system. Sometimes people eliminate their system right off the bat. If you have think about residential, they might do heat pumps. They don't cut the cord right away. They might, keep that as a backup system, use their heat pumps, but they still have something. And so allowing for a new rate design that understands it's not one or the other, increasing those geothermal pilots, targeting new electrification, and I think the kind of continued scrutiny of these hybrid approaches, really to eliminate or at least soften the exit fees on very costly new infrastructure. So those are kind of some of the large considerations just in Massachusetts, but once again, every state has fairly similar audacious goals for 100% renewables. But electric is only one part of the larger problem. To get there, you'll really need to focus on the scope one, whether it's in the buildings or campuses or in the electric infrastructure in generation facilities. So with that, I guess we did want to open it up to questions, but also, it doesn't need to be specifically about Massachusetts. I think this is a larger question that lots of people are grappling with at the legislative side, end user side, and the residential.
Thanks, Zach. Maybe I can just kind of summarize, I guess, the three gas components we talked about: natural gas commodity, to domestically produced, for the most part, domestically consumed resource that we're flush with at the moment, and prices are very cheap for that commodity. We're enjoying right now a relatively low cost to bring that gas into New England, but that market, the basis market, that can be influenced by what happens globally and also seasonality. We pay a premium for the winter gas, and going forward, that basis market is very much in flux. We've seen that happen when global events have occurred outside of our control. So keep a close eye on that. And lastly, the delivery costs, local distribution companies, prices are, right now, fairly stable, but thinking about the future as some of these policies start to impact gas use and gas customers, it'll be harder and harder to recover, those delivery costs, fixed delivery costs, when the volume of gas flowing through that system starts to decline. So something to give some consideration to and think about, and that kind of wraps up our presentation. So Troy or Dovev, happy to turn it back to you. I don't know if you had an intention of moderating from here forward.